All right, ladies and gentlemen, we have more vocabulary. Today we're talking about circles that includes angles and polygons. And so you want to make sure you pay attention to every little detail here. Make sure you understand the theorems. Let's jump right into it. Inscribed angle. An angle that is inscribed. It says an inscribed angle is an angle whose vertex is on the circle and whose sides contain the chords of a circle. So a vertex is on the circle. That means you got a circle here, and the vertex is on the circle. The vertex is where the angle changes. So the vertex is on the circle, and notice the sides are chords. All right. Intercepted arc, the arc that lies in the interior of an inscribed angle and its endpoints on the angle is called the intercepted arc. So here's an angle. Here's the arc that's intercepted. Not this back here, but where it opens to, that's called the intercepted arc. So from here to here is the intercepted arc of this angle I just drew. All right. Inscribed polygon is a polygon if all its vertices lie on a circle. So if I made this right here into a triangle, see, that's a polygon, and all its vertices are on the circle, this is called an inscribed polygon. Basically, a shape that all its vertices are on the circle, or that's all included inside the circle. A circumscribed circle. A circumscribed circle is a circle that contains the vertices of an inscribed polygon. So this circle right here is called a circumscribed circle because it contains all the vertices of this polygon. Okay, so these are definitions, terms that we need to know. All right, let's use some of this. Here's our first theorem. The measure of an inscribed angle. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. Okay, so what I like to tell people is this. If your vertex is on the circle, then your angle is going to be half of what the arc is, or your arc is going to be double what the angle is. So in essence, if you're going this direction, from the arc to the angle, it's divided by 2. But from the angle to the arc, it's times 2. You might want to write that down. So I always let people think about it. What do I know and what am I trying to find out? In this particular theorem, it's basically saying that if you have an inscribed angle, meaning your angle is on the inside of your circle and the vertex is on the circle, the angle here is going to be half of whatever the arc is. Or the arc is going to be double the angle, however you look at it. So this is times 2 going this direction. So that's times 2 going this direction. And this is divided by 2 going this direction. All right. So going that way is divided by 2. Going this way is times 2. And what do I mean by going this way or that way? From the arc to the angle, you divide by 2. If you know the arc and you're trying to find the angle, you divide by 2. If you know the angle and you're trying to find the arc, you multiply by 2. Let's use that in this example here. All right, it says find the indicated measure in circle P. So they want us to find the measure of angle S. All right, so they want us to find this right here. I know the arc. See, this is the intercepted arc. Arc RT is the one that intercepts this angle S right here. Hopefully you understand that. So if I know the arc and I'm trying to find the angle, say I'm going from the arc to the angle, I divide by 2. So that means the measure of angle S equals 30 degrees. All right. And now they want to know measure of arc RQ. RQ is this right here. Okay. They want to know the measure of arc. All right. So RQ is here. I told you guys several times, if you've been listening to me, that it's always important to figure out where your semicircles are. For example, RS here is a semicircle. That means all this arc right here is 180 degrees, and so is this arc right here. All right? And so I need to find out what QS is. if this angle is 37 and I need to find the arc, so I'm going from the angle to the arc, this is when you multiply by 2. So the measure, oops, yeah, that is B, excuse me. The measure of RQ comes from first, not angle, the measure of RQ comes from first knowing what QS is. So QS, arc QS equals 134 degrees. How did I get that? This is 134 degrees, and that's because you multiply by 2 when you know the angle. Now, what is the rest of this? From here to here is 180 degrees, right? From here to here. So I do 134, and I take that from 180, and so I find the measure of arc RQ equals 46 degrees. Okay? So I wasn't asking just for QS, I was asking for RQ, and I had to figure out what this was first and then subtract it from 180. Again, how did I know 180? Because that is a diameter. Moving on. The next theorem says if you got two inscribed angles of a circle intercept the same arc, then the angles are congruent. Notice that ADB and ACB both have the same endpoints of that arc right there. That means that these two angles, D and C right here, are congruent. So it's just that simple. Alright, so it says here, name two pairs of congruent angles in the figure. Alright, two pairs of congruent angles. Alright, angle SPR and angle SQR intersect the same arc. You see that? So this angle and this angle intersect the same arc right here. Hopefully you see that. Alright, and the same thing goes in the other direction. That angle PSQ, so this angle right here, and angle PRQ, and this angle right here, intersect this same arc. So those are two sets of congruent angles in the figure. Alright? Now, here's our next theorem. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of the inscribed angle is the diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is right angle. Okay, so in English, what that's saying is, if B right here is 90 degrees, then the intercepted arc has to be the diameter. The end point here has to be at the end of the diameter of the circle, which means that the intercepted arc is going to be 180, which makes sense. If this is 90, then arc AC is a semicircle, which means it's 180 degrees. All right? The next one says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So that means angle E plus angle G equals 180. Also, angle F and angle D equals 180. So this one makes sense. If that's 90 degrees, then times 2 gets you 180. Divided by 2 gets you 90, going either direction. Here, opposite angles are supplementary. All right? Let's look at this. All right, find the value of each variable. Okay, find the value of each variable. If I know that this angle, see, this is an inscribed polygon. All right, every vertex or vertex is on the circle. So if this one was 100, then Y has to be 80, right? Because they're supplementary. And this one is 88, then the opposite side is 92. Should have known that. Why? Where am I getting these numbers from? Because the opposite angles equal 180. And so all you got to do is subtract that from 180 and you find the opposite side here. All right? And I know that because it's an inscribed polygon, meaning all its vertexes is on the circle. All right. So how do I find X and Y here? Well, the key is understanding in B that 8X plus 4X equals 180. That's the rule. And 3Y plus 3y equals 180. Okay, that's the rule. So this is 6y equals 180, and this is 12x equals 180. Divide by 12. Divide by 6. Why am I working these together like this? I have no idea. So 180 divided by 12 is 15. And 180 divided by 6 is 30. Yep. Since I'm solving for x or y, they don't get a degrees. That's just x equals and y equals. Okay, so quick review. You got a theorem that says if your angle, your inscribed angle is 90 degrees, then it's got to intersect. The endpoints here has to be on the end of the diameter because that's going to be 180 degrees. It has to be, and it works both ways, backwards and forwards. Inscribed polygon, opposite angles are, excuse me, I keep saying inscribed polygon. It's actually inscribed quadrilateral. Opposite angles are congruent. Wrong. Opposite angles are supplementary. I'm sorry, I'm still sick. That's my excuse. Opposite angles are supplementary here. Then we talked about if two angles intercept the same intercepted arc, then they are going to be congruent, and that makes sense. These two angles here intercept the same arc, so their angles are going to be congruent. All right, and then we talked about the measure of an inscribed angle. Now, this is different. I just want to make sure we're clear. This is different from if you have a what do you call those? If you have a central angle. A central angle is different because a central angle, it's going to be the same as the arc. So if the angle's vertex is in the center, then it's going to be the same as the arc. But if it's on the circle, then you got to do the angle is half of the arc, or the arc is double the angle. All right? And then you have these definitions here. If you got any questions, hopefully I didn't make that more difficult. If you got any questions, let me know.